Okay, let's have a look at this here, rates of change. I'm sure you're used to seeing dy dx. Now, it basically means the rate of change of y with respect to x, okay? We would generally call that the slope. So, what's happening to the y value? Is it going up? Is it going down as x is going along, okay? That's basically what the slope is defined as. But you can also have different variables here. So d or dt, that's basically looking at the radius and comparing it to time. So that's going to be the rate of change of the radius. So the radius of a circle or the radius of a sphere is increasing or decreasing with time. So the rate of change of the radius with respect to time. That's just a shorthand for that. Okay. Now, just an important thing here. A lot of times you'll just see this. Find the rate of change of the radius. Okay. The with respect to time bit is implied. So that is not given in the question. This is not given. So that is implied. Okay, and that's important. So they're kind of hidden in the questions. Now, the one below here, what does this mean, dA dr? Well, if A stands for area and R stands for radius, dA dr is just the rate of change of the area, the rate of change of area, and in this case, with respect to the radius. So, if the radius of something is changing, like a circle is changing, obviously the area is going to change, and the rate is what that this tells us. You can also have dA dt, and that's telling you as the time goes on, after 20 seconds, after 30 seconds, how is the area changing. You could have dV dt, that's going to tell you, perhaps V would stand for volume. How is the volume changing after 20 seconds, after 2 seconds, etc. Okay. So let's look at this question here. It might kind of help clear things up. So a stone is dropped into a still pond and it causes a circular ripple whose radius increases at a rate of 1 meter per second. Okay, first thing we're going to have to do here is get this into derivative form. So the question is, how rapidly is the area enclosed by the ripple increasing? Okay, so we can say we are looking for this. The radius increases at a rate of 1 meter per second. Okay, so that's going to be dr dt. That's basically what it's saying. The rate of change of the radius with respect to time, which is given in this question as 1 meter per second. Okay, so this is given to us. This is going to help us solve this. Okay, so if you can picture it at the start, well, this is seconds, and well, let's say the radius is here. At 0 seconds, well, nothing has happened yet. There is no radius. At 1 second, it's increasing at 1 meter per second. So the radius is 1. At 2 seconds, the radius is 2. At 3 seconds, the radius is 3. At 4 seconds, the radius is 4. At 5 seconds, the radius is 5. Okay, that will help us later. But how rapidly is the area enclosed by the ripple increasing? This can be the tricky bit to work out. Okay, so what they're actually wanting us to find out is dA, it has to do with A. How is the area changing with respect to time? How is it increasing? Okay, so we are looking for, we want to find out what is dA dt. This is what we want, dA dt. But we don't have any formula with A and T in it. So this is, you know, a slight issue here. But watch what we'll do. We know that we want to find out this. So we're given dr dt. Now I'm sure you'll see that the right hand side and the left hand side of this equation are not equal. But what we'll do is this. we are looking, and this is the bit we need, and this is the critical bit in all these questions. We are looking for something to go on the right hand side to make the right hand side and the left hand side equal. Okay, so if you notice here, there's a dA at the top here. There's no dA on the right hand side, so there must be a dA here. Okay, at the bottom we have a dt here, we have a dt here, so we're okay with that. But look what happens if we divide by dr, they will cancel, and you'll be left with dA dt, which is what we're looking for. Okay, so what we're going to do now is we're going to look at this here. This is the new thing that we've created. Okay, we're looking for a formula that has A and R. Now, I'm sure you know that the area of a circle is pi r squared. Okay, now we can easily work out what dA dr is. We just differentiate with respect to r, we'll get 2 pi r. Okay, so now we start filling everything in that we want this. We want how the area is changing with respect to time. We are given that the rate of change of the radius with respect to time is 1. Okay, so we're given that. No, we don't want that to happen. So we're given that. And we have just worked out that the rate of change of the area with respect to the radius is this here. It's 2 pi r. Okay. So that means that the rate, if we multiply those, we just get 2 pi r. Sorry, should we just store? Okay, so the rate of change of the area with respect to time is equal to 2 pi r. Now, in this question, they wanted us to do it for how rapidly is the area enclosed by the ripple increasing after 5 seconds. So after 5 seconds, the circle has a radius of 5. Okay, so it's going to be dA dt. Now what we do is this, we do when the radius is 5, this is how we show when the radius is 5, is equal to 2 multiplied by pi multiplied by 5, which is equal to 10 pi. Now, what units are we going to use here? Well, it's area, so it has to be centimeters squared, meters squared. In this case, it's meters squared. And is it seconds? Is it minutes? Well, it has to be per second, meters squared per second. Okay? So, what's happening at 5 seconds? Well, at 5 seconds, or when the radius is 5, the area of the circle is increasing by approximately 10 times 3.14, approximately 30 meters squared per second. If we go down to, for example, at 2 seconds, we'd have 2 by pi by 2. It would be increasing at approximately 4 times 3, 12 meters squared per second. So it depending on here, let's say this is 2 seconds if we look at the picture, and out here we've got 5 seconds, let's say. As time goes on, as the radius increases, the rate that the area increases is what we're trying to work out, is not fixed. Okay, so it depends on the radius. This is what this r is telling us here, and that's what we just worked out. So there's our answer, 10 pi meters squared per second.